here is an example problem. It's not one of the homework problems, but hopefully by working through this problem, you get a sense of how you work through these problems in general. So what this says here, and you should know this from the reading, what this is it's a representation of an argument. The conclusion is P. This symbol here means therefore. So we have three premises and a conclusion. So the argument is saying if R is true, then Q is true. That's one of the premises. If Q is true, then P is true. That's another premise. And R is true. So granting those three premises, it follows that P is true. How does that work? Well, suppose that R stands for it's raining, and Q stands for I'm cold, and P stands for I shiver. Then the first premise says if it's raining, then I'm cold. The second premise says if I'm cold, then I shiver. And the third premise says it is raining. So in a situation in which all three of those claims are true, it's going to be true that I shiver. Since it's true that it's raining, and it's true that if it's raining, then I'm cold, it must be true that I'm cold. And it's true that if I'm cold, then I shiver. So since it's true that I'm cold, and it's true that if I'm cold, then I shiver, it must be true that I shiver. That's the reasoning we're going to reconstruct in this derivation. So every derivation begins with a show line. A show line is where you set out what you're trying to derive, what you're trying to prove. And what you're trying to prove is the conclusion. So every derivation begins with a sentence, with a line where you say show, and you just type in the words S-H-O-W, with a space, and then the conclusion. In this case, the conclusion is P. Some of you might misread this and think that the conclusion is if R then P, taking that symbol there to just be another way of writing the arrow, and so thinking of this as another way of writing a conditional. But that's not what that is. That symbol there means therefore, and it's separating all of the premises from the conclusion. So our conclusion here is P. Now I'm going to hit enter or return to get another line. The work that you do to try to show P is now all going to be indented underneath the show line. So I'm going to enter a space to indent this line under the show line. I actually like to enter two spaces just because I think it looks cleaner. So I'm going to enter two spaces. And you notice that when I entered that space, the software automatically put a little vertical bar there to help indicate that this is all underneath that show line. You don't want to type that bar in yourself. The software is just going to enter that bar in automatically as a visual indicator of what's going on. So you can always start a derivation by entering in the premises. So I'm going to type in the first premise, if R then Q. And now I need to justify line 2. So I enter some spaces. My justification for line 2, for writing down if R then Q, is I'm allowed to assert that because it's a premise. So I type in a colon to indicate that what I'm about to give is my justification, and then PR is short for premise. And now I'm going to repeat that process. You don't need to line everything up. It will work fine if they're not aligned. But you'll notice that I failed to do something here. This is not indented properly, so there's no vertical line there. So I'm going to fix that by lining it up there. Okay, so two spaces, lines that up. It's nice and fixed. Again, space to indent my premise. R, this is my third premise. It's another premise. That looks kind of ugly to me. I'm going to go back up and add extra spaces just to clean it up. Okay, so I've entered in my three premises. Now it's time to apply rules in order to try to reason from lines 2, 3, and 4 to what I'm trying to show, my conclusion on P. Sorry, my dog is barking in the background. Fletch, stop barking. That doesn't usually stop him from barking. So if you look on line 2 and line 4, line 2 says, if R is true, then Q is true. Line 4 says, R is true. So one of our inference rules, one of our patterns of inference that we know is obviously valid, is that if you've got a conditional and you have its antecedent, you can infer its consequent. I'm going to do that now. I'm going to get Q from lines 2 and 4 by applying the rule modus ponens. That's the name for that rule. So I type in the name of the rule after the colon, and then I type in the 2 lines, 2, 4, and hit enter. And over here, you'll notice some things. The question mark means that I haven't completed this proof yet. So once I've completed the proof, that question mark will go away. The plus sign means that I've done something that is acceptable. If you hover over it, you'll get something that indicates roughly what you've done. It might not be very helpful right now, but as you get better at this, that'll allow you to reconstruct some of the steps that you took. This warning sign indicates a typo, something that can't be read, something that can't be parsed. Right now, that's just because I've got a space on this line. So it thinks I've tried to type something, but it doesn't see what. Actually, I don't even have a space. It's just because I've got a line there. Okay. So I've now shown that Q is true, because that followed from the premise I had on line 2 and the premise I had on line 4. On line 3, I have if Q is true, then P must be true. Since I know on line 5 that Q is true, I can now infer that P is true. So I type in P, and then come over here and enter in my justification. This is another application of the rule modus ponens. Again, if you're not sure what these rules are, if you're like, modus what? Where did that come from? What are you talking about? You need to go back and read that part of the chapter. The chapter introduces the rule modus ponens, and it introduces the rule modus tollens. You need both of those rules. You need to understand them and how to use them. So if your understanding of them is still loose, now is the time to go back and see if you can tighten it up. So MP 3, 5. You can hit enter. Notice that line 6 is what I set out to show. Line 6 is the conclusion that I was after. So to finish off this derivation, so if I hit submit right now, it'll say not yet finished. To finish off this derivation, I need to explain why what I've done counts as showing P. Later on, we're going to have several different forms of derivation. So there will be several different ways you can succeed at doing what you needed to do to show what you set out to do. For now, the only method of derivation we have, the only kind of derivation we have, is called direct derivation. A direct derivation is where you manage directly to show the thing that you needed to show. Or other kinds of derivation, one of them will be called indirect derivation, one of them will be called conditional derivation. They'll have a different kind of success condition. You do something else that's more complicated. But you don't have to worry about that. For now, you just need to know that this derivation, all the derivations in this chapter, are direct derivations. To show that you're done without indenting, so at the same level of indentation as your show line, you give your justification. Your justification is that this is a direct derivation, and you point to the line where you got what you needed to get. You point to the line where you managed to get the thing you were trying to show. So in this case, line 6. And at this point, you're done with the derivation. Since it's correct, the top area here has become highlighted green to indicate that it's correct. You can hit submit and you're good to go. Let me go back and walk through a few common mistakes that you might have made so that you can see what those look like. One common mistake is to forget to type in the colon. So if you don't type in the colon, you're going to get a parsing error over here. You're going to get this warning sign. And it's not going to work. It's not going to know what you're trying to do. The colon separates the part of the line that has the sentence that you're asserting from the part of the line that explains your justification for asserting that sentence. So you need the colon there. Another thing that could go wrong is that you might fail to indent. And if you fail to indent, you can see that breaks everything. If that line 2 isn't properly indented, then the software doesn't know that what you're trying to do is enter that premise as part of a proof for what you wrote down on line 1, that show line. So that needs to be indented. It's fine if the indentation is ugly or inconsistent. It just needs to be indented somehow. I'd encourage you to be consistent and neat because it makes everything a lot more readable. Another thing that you might do is you might apply the wrong rule. So if I tried to apply MT to lines 2 and 4, that's modus tollens, that's one of the other rules that is introduced in chapter 3, I'll get an error message. The error message is more complicated than I'd like it to be, but what it's trying to explain to you is that lines 2 and 4 aren't an instance of the pattern. They don't fit the pattern that is modus tollens. So this is not a proper application of that rule. I can fix that. Another thing that could happen is that you might forget to put a comma between the line numbers. You might say modus ponens 2 and 4. The software reads that as you're trying to apply modus ponens to line 24. That's confusing because line 24 doesn't even exist, so it doesn't know what to do. The software will be perfectly happy if you separate the numbers just with a space or if you separate them with a comma, but it'll be confused if you don't separate them with anything at all. Another thing that can happen that goes wrong is that you indent your direct derivation line. So when you're done, when you've succeeded, the line at which you say, yay, I'm done and I've succeeded, should not be indented like the other lines. The lines that are indented are the work that you do in the process of showing P. On line 7, you're asserting that you've succeeded. It's the equivalent to what mathematicians do at the end of a proof when they write down the abbreviation QED, which is an abbreviation for a Latin phrase that just means it has been proven or it has been demonstrated. So this is your QED line. Your QED line should not be indented along with the lines where you were doing your work. So that's how you use the software. I know there's a lot of moving parts, but I think once you get the hang of it, it'll be pretty straightforward. Of course, you're trying to learn how to use the software, and at the same time, you're trying to learn how to do derivations. And doing derivations is its own hard thing, and we'll talk a lot about this in class. But I hope that maybe for